toluene, C. ethene, D. pentanal. Number 3. What is the compound form when benzene undergoes hydrogenation? Number 4. Which compound of benzene is used as explosives? Number 5. How can benzene be obtained in nature? Answers. Question number 1. Which of these compounds exhibits resonance? We know from the topic treated earlier that one of the characteristics of benzene is that it exhibits resonance due to the delocalization of pi electron, which confers stability to benzene ring. So the answer to the question number 1 is B, which is benzene. Question number 2. Which of these is an aromatic compound? An aromatic compound are families of benzene. So, owing to the options, cyclohexane is not, cyclopentane is not a family of benzene. B. toluene. Toluene is a family of benzene because it is a benzene ring, but only with attachment of CH3. C. ethene. Ethene is not a family of benzene because it contains 2 carbon atoms. Then D. pentanal is not also a family of benzene because it contains 5 carbon atoms. So the answer to this question is option B, which is toluene, because toluene is one of the families of benzene. Question number 3. What is the compound form when benzene undergoes hydrogenation? The compound form when benzene undergoes hydrogenation is cyclohexane. In the presence of nickel catalyst and at 180 degrees centigrade, it will give you cyclohexane. So the answer to question number 3 is cyclohexane. Question number 4. Which compound of benzene is used as explosives? Owing to the uses of benzene, the compound that is used as explosive is toluene. Question number 5. How can benzene be obtained in nature? The only way to obtain benzene in nature is by destructive distillation of coal, where the coal tar, that is one of the byproducts, is a constituent of benzene. So the answer to question number 5 is destructive distillation of coal. Quantitative and qualitative analysis. What do we understand by quantitative? Quantitative is telling us the measurements with respect to volume and is also known as volumetric analysis. While qualitative is talking about the measurement or determinations of cations or anions, salts, in qualitative analysis. So qualitative analysis tells us how the color of salts varies with respect to the reagent that is being used. Under this, we talk about acid-base titration. What is titration? Titration, the process whereby you introduce a substance, usually an acid, into another, which is usually a base, such that the endpoint is attained. Otherwise, you can also titrate a base against an acid, but it is very rare in the modern day world. Not that it is not possible, but it is rare. Acid-base titration. When we talk about acid-base titration, this is the reaction between an acid and a base. Common terms used as or used in acid-base titration is indicators. We have different kinds of indicator depending on the concentration of the acid and base. If you are titrating a strong acid against a weak base, we make use of methyl orange. If you are titrating strong base against a weak acid, we make use of phenolphthalein. If you are titrating strong acid against a strong base, we can use any of the indicators. Redox titration. In a redox titration, the oxidizing agent is titrated against a reducing agent. When we talk about oxidizing agents, what do we understand by oxidizing agent? An oxidizing agent is an electron acceptor, while a reducing agent is an electron donor, or is an electron donor. Example, when potassium tetraoxomanganate 7 is titrated against ethane dioic acid or its hydrates. Test for oxidants and redundants. In the case of oxidants, they are the oxidizing agents, and a simple test for oxidants is done by addition of solution of iron 2 chloride to an oxidizing agent. When iron 2 chloride, which is 2 plus, the iron 2 here is introduced into, when an oxidizing agent is introduced into a solution of iron 2 chloride, which is iron 2, green in color, it oxidizes it to iron 3, which is brown in color. So what we have understand, or what we have understood here, is that when this oxidizing agent is introduced into green solution of iron 2 chloride, it oxidizes the iron 2 chloride to give brown colored iron 3. Test for reductance. This is done by addition or adding a reducing agent to a solution of acidified potassium tetraoxomanganate 7. Potassium tetraoxomanganate 7, when it ionizes, it gives this ion. So this ion, which is tetraoxomanganate 7 ion, is purple in color. When it is being introduced into a reducing agent, it becomes reduced to manganese 2 ion, which is colorless, where you have other byproducts such as this. You have 5 ion. So the subject of matter here is that this tetraoxomanganate 7 ion, which is purple, is being reduced by a reducing agent to manganese 2 ion, which is colorless. Volumetric analysis. Procedure for titration. Place a known volume of alkali in the conical flask using the pipettes. What is an alkali? An alkali is a basic hydroxide which is soluble in water. Record the initial volume of the acid in the burette and add 2 drops of the indicators. The indicator that must be used here must be in 2 drops to ensure that the reaction reach completion at the exact time. Perform the titration by running the acid in the burette until color change is observed. Computing a table for titration and calculating the average titer. This topic, volumetric analysis, is also known as quantitative analysis, where we measure in quantity. Now, if you take a look at the diagram on the board, you will see that you have your retort stand. This is your burette that is clamped with the retort stand. The acid is meant to be in the burette, while the pipette, it is the base. The pipette is usually calibrated. The standard calibration is 25 cm3. So before titration begins, you pipette the required volume, which is usually 25 cm3, into the beaker. This is the beaker. Then you add 2 drops of indicator. So having added 2 drops of indicator, then one brings it to this position where you have the acid in the burette.